All right, in this video, we're gonna take a look at the first introduction to quadratic functions. Um, this is something you may be seen before, quadratic functions, parabolas, things like that. Our essential question is, how can I identify characteristics and graph parabolas that are written in vertex form? So we're gonna talk about what that means, as well as take a look at some of the ways that we can graph these parabolas. Okay. So first of all, this shape that is shown right here is what's called the parent function. Okay, so the parent function is the most basic quadratic graph. The word quadratic just means that it contains x to the second power. Okay, so anytime you have x to the second power, this is going to be quadratic. Okay, and a quadratic graph is going to create this shape that's called a parabola. So it comes down, it bottoms out, and then goes back up. So if we look, there's 5 main points that we can read on this basic parabola. Okay, and those 5 coordinates, if we just go left to right, are -2, 4, because -2 squared is 4. -1, 1, because -1 squared or times itself is 1. Then there's 0, 0. There's 1, 1, and there is 2, 4. Okay. So these 5 points are going to help us create and transform the parabolas. We've already talked about transforming absolute value functions as well as some other weird functions. In this unit, we're going to focus on quadratic graphs and these parabola shapes. So a couple things to talk about for the parent version of the parabola. It does have a vertex just like absolute value did, and that vertex is right here where the graph switches from increasing to decreasing. So it's coming down in the beginning, hits the vertex, and then comes back up. So that vertex is a coordinate, and that coordinate is 0, 0. Just as with absolute value, this parabola has a line of symmetry that goes straight down the middle. Vertical lines are always written in the form x equals. In this case, the line of symmetry is right through the y-axis, and that line is x equals 0. Okay. Then it's max or minimum value. So what is the highest or the lowest that this graph gets to? Now, the arrows aren't drawn here, but we assume that that graph will continue going up. So there's actually not a maximum value on this graph because it's just going to continue going up and up and up forever. So there is a minimum value, and the minimum value is that vertex. So in this parabola, there is a minimum value, and that we will always write as a y-coordinate. So in this case, it is y is equal to 0. Okay, and again, minimum, we're talking like as far as y-coordinates are concerned. So the domain is the list of all x-coordinates that the graph will hit. But because the parabola is continuing in both the right and the left direction, the domain is going to be all real numbers. And you may have seen that all real numbers can be expressed with this like double R symbol. Okay. And then finally the range. And again, you want to take a look at the vertex for the range. For the vertex, the graph goes up from there. So we're going to say the y values that this graph hits, that this parabola hits, is everything that is greater than or equal to 0. Because here's the bottom of the graph at 0, and then we're going to hit every y coordinate above 0. We are not going to hit any of the y coordinates below 0. Okay. So these are some of the basic characteristics for what's called the parent parabola, that y equals x squared. Okay. Now, if we want to graph something other than y equals x squared, something like y equals 2x squared, what we've seen in the past is that 2 actually causes a vertical stretch. Okay, so we're essentially multiplying the y coordinates by 2. And another way to see that is we're going to create a table of values. Now, we're just going to use the typical -2, -1, 0, 1, and 2, like we did on the previous, right? If you go up here, -2 to +2. But now what this is saying is in order to get the y coordinate, you need to take 2 times the x coordinate squared. And because of order of operations, we're going to do x squared first, and then we're going to multiply by 2. So what is this number squared? Well, -2 squared is 4. Double it or multiply that by 2, and we get 8. Negative 1 squared is 1, times by 2 is 2. 0 squared is 0, double it. 1 squared is 1, double it. 2 squared is 4, double it. Okay. Now if I plot these points, negative 2 comma 8 is all the way up here. Negative 1 comma 2 is up here. 0, 0, so the vertex is still in the same spot. And then we have our other 5 points. So we have this sort of, it's not a V-shaped graph because it does curve, it does get steeper as you move further away from the vertex. Okay. So if you compare this graph to the previous one, you can see this is a little bit wider or rounder. This one is a little bit more aggressively curving up and also drawn very poorly because it's by me. The vertex, where's the vertex of the graph? Vertex is still at 0, 0. Axis of symmetry is still right down the y-axis. So this is still x equals 0. The vertex is still a minimum, and that minimum is y equals 0. The domain is still all real numbers, and the range is still y is greater than or equal to 0. So none of those characteristics changed when we multiplied by 2. It made the graph steeper, but it didn't move the vertex, and if it doesn't move the vertex, most of the time, those other characteristics aren't going to change. Okay. Well, what happens if we put something like y equals negative 1/3 x squared? Now, you may remember that this negative sign is actually going to be an x-axis reflection. If you don't remember, that's fine. And the negative 1/3, or sorry, the 1/3 is actually a compression. So this is going to be a little bit wider of a graph, and it's x-axis reflection, so it's going to open down instead of opening up. But if you don't remember those transformations, it's fine. We're going to create the graph by using coordinates. Now, what is going to be tough, if I use my typical negative 2, negative 1, 0, 1, and 2, I'm going to be trying to take 1/3 of numbers that aren't divisible by 3. Okay, so pro tip here, if you are trying to graph and your denominator is 3, I am going to pick numbers for my x coordinates. Okay, I'm going to pick x coordinates that are divisible by 3. So I want divisible by 3. Now, I can always use 0, right? 0 is going to be easy. 0 divided by 3 is going to be 0. Okay, but then I'm going to use positive 3 and positive 6. And then just so I can get a couple negative numbers as well, I'm going to use negative 3 and negative 6. So now what we're going to do is we're going to take x and square it, and then multiply by negative 1/3, which is actually the same as dividing by negative 3. You can look at it either way. So if I take negative 6 and square it, that's positive 36. Negative 1/3 times 36 is going to be negative 12. Okay. Negative 3 squared is 9, times negative 1/3 is negative 3. 0 squared is 0. Take a negative 1/3 of that, still get 0. 3 squared is, again, positive 9, so this becomes negative 3. 6 squared is 36, times negative 1/3 is negative 12. So negative 6 comma negative 12 is going to be all the way down here. Negative 6 comma negative 12. Negative 3 comma negative 3 is right here. Still have 0, 0. 3 comma negative 3 is right there, and then 6 comma negative 12 is all the way down here. So might be a little tougher to see, but we do actually get a wider parabola. I'm going to put arrows on the end because the graph does keep going. That's a little bit wider than our parent function was. Okay, but the key here, just to make your life easier, pick numbers in the x coordinates that are divisible by 3. Okay, our vertex hasn't moved, but you will notice that now the vertex is at the top of the graph, so it's going to change some things later on. Line of symmetry hasn't moved. My line of symmetry is still straight down the middle, so it's going to be x equals 0. Now, though, I don't have a minimum value because this graph is going to keep going down and down and down and down and down. So my vertex is actually a maximum value. And that maximum value is y equals 0. Domain is boring. It's still all real numbers because this graph is still going in to the right and to the left forever. And then finally the range. And the range does change because the vertex is at the top. The list of all y coordinates this graph is going to hit is less than or equal to 0. Okay, so because my vertex changed to a maximum, that switched my range to y is less than or equal to, because it's going down. Okay. So that's how we graph if there's a vertical stretch or an x-axis reflection at the front of the graph. Now, there are two forms of quadratic equations. The one that we're going to focus on today is what's called vertex form. The reason that we are going to focus on vertex form is because we already know if you subtract a number inside the parentheses, that's going to move the graph right or left. If you add or subtract a number outside, that's going to move the graph up or down. And those are the only types of movements that move the vertex from 0, 0. So the only way to move the vertex away from 0, 0 is to slide the entire graph or translate it left and right as well as up and down. And then we know that this a value in front is our vertical stretch or compression. In a future lesson, in a future video, we'll talk about standard form, which is ax squared plus bx plus c. For today, that's not the focus of what we're working on here. Okay? So vertical stretch or compression. So all the same transformations that we've been using are coming back. It's just a matter of how do we use it? How is it different than absolute value? Okay. So here's an example of an equation in vertex form. Okay. I've got the -2 out front, which tells me a couple things. It's an x-axis reflection as well as a stretch. So I know it's going to open down. It also is moving to the right 5 because of this -5. And this is moving it up 3 and right 5. Okay. Now, because I know it's moving right 5 and up 3, normally the vertex is right here at 0, 0, but I know that any translation is also going to move the vertex. So I'm going to go ahead and move right 5 and up 3 and put the vertex on the graph right away. I'm going to go ahead and label it as the coordinate 5, 3. You'll notice that this was -5, but the coordinate itself was +5 for the x. But then the y is easier because this is +3 and that's +3. Okay. Now, how do I get the rest of the graph? There are many ways to do this, and you are going to learn different ways from different teachers. This is the way that I like to do it. Okay. Since I've already taken care of the right 5 and up 3, I am just going to focus on this -2. Okay. So here's what I like to do. I'm going to make a table of values for the equation y equals -2 x squared. So I'm going to pretend like the right 5 and the up 3, the -5 and the +3, are not in this problem for right now. Okay. Because the a value, that number in front of x squared, isn't a fraction, I can just use my -2, -1, 0, 1, and 2. So then I'm just going to do what we've already done a couple times. I'm going to square each of those numbers and multiply it by -2. So -2 squared is 4, times by -2, you get -8. -1 squared is 1, times by -2, you get -2. 0 squared is 0, 0. Now you may have noticed by now that these x coordinates repeat themselves, or sorry, the y coordinates repeat themselves on either side of the vertex. That's not a coincidence. Because the parabola has symmetry, you're going to have repeats of y coordinates on either side if you use the same x coordinate. Now here's the jump we got to make. Okay, normally the vertex would be at 0, 0. But we know that the vertex is actually at 5, 3 right here. Okay, so here's how I like to do this. This might not make sense the first time, and if it doesn't make sense at all, let me know, and I can show you a couple different ways to do this. Okay, but I am going to graph these 5 points, but I'm going to pretend like this point right here is 0, 0. Okay, so instead of counting from the actual origin, I'm going to count from where I know the vertex to be. Okay, so for instance, -2, -8 is my first point here. I'm going to graph that, but I'm going to treat the vertex as 0, 0. So -2, 1, 2, 3, 4, 5, 6, 7, 8. Now the reason I like to do that is because if you would have actually graphed -2, -8, it'd be down here. But guess what? If you just move this point right 5 and up 3, we end up in the same spot. So some people like to graph the original coordinates and then move them all right 5 and up 3. What I found to be a little bit quicker is we're just going to graph these numbers, but we're going to use our vertex as our new origin, basically. Okay. So -2, -8 is graphed. My next point is -1, comma -2. So -1, -2. Again, treating this as 0, 0. -1, -2 would be right there. Then it was +1 and -2, which would be right there. It has symmetry, so you're gonna be able to build. If you have the left side of the parabola, you can kind of just reflect and build the right side of the parabola. And then +2, comma -1, 2, 3, 4, 5, 6, 7, 8. Those are my last coordinates. Okay, so now I have graphed this parabola y equals -2. So here's what we have the graph of. -2 times the quantity x minus 5 squared plus 3. Okay. You might think that's a weird way to do it. Again, I've just found like that is one way that clicks with me. And really, as long as you're willing to accept the idea that this is my new 0, 0, it's relatively straightforward. Where is the vertex? We already know that's at 5, comma 3. Where's the axis of symmetry? Well, the axis of symmetry is always going to be a vertical line that goes through the vertex. So this hits the x-axis at +5. So we're just going to say x equals 5 for our axis of symmetry. Since the vertex is at the top of the graph, the vertex is a maximum value, and that maximum y value is, what is it, 3, +3. Domain is still boring because the graph will always go forever to the right and forever to the left with parabolas, so this is always going to be all real numbers. And then what's the range of this graph? Well, again, from the vertex, the graph is going down, so we're going to say y is less than or equal to 3. Okay, so there's always going to be a link between these values, and there's always going to be a link between the x-coordinate of the vertex as well as the axis of symmetry. Okay, so that is one way to graph in vertex form. And I think if you practice this like new 0, 0, it'll make sense. Okay, if we try this again, okay, I'm going to look at this, and I know that my translations are left 1 and down 7. So if I take my original vertex and I instead move it left 1 and down 7, okay, it's going to be right down here at -1, -1, -7. Vertex as a coordinate, -1, comma -7. Okay, so I'm going to write that right here. Now, the only thing I haven't dealt with is the 1/2. So for my table of values, I'm going to write y equals 1/2 of x squared. Now again, 0 with 0 is always nice because you square 0, it's 0. Multiply it by anything, you're going to still get 0. But as we said earlier, this is going to be easier if you use coordinates or x coordinates that are divisible by 2 in this case. Right? I don't want to put in 1, square it, and then cut it in half and try to graph a decimal. So instead of using 0, 1, and 2, I'm going to use 0, 2, and 4, and then just go to the negative side with -2 and -4. Okay. So square the x-coordinate, multiply it by a half, or cut it in half. So -4 squared is 16, half of that's 8. -2 squared is 4, half of that. 2 squared is 4, half of that. 4 squared is 16, half of that. Okay. Now again, I'm going to graph these coordinates, but I'm going to treat this vertex as 0, 0. So -4, comma 8 would be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's going to be right there. -2, comma +2 for my new vertex is right there. 2, 2 is right there. And then 4, comma 8 would be up here. So this gives me this parabola shape. Oh gosh. That is a little bit wider than our typical parabola because the 1/2 is technically a vertical compression. Where's my axis of symmetry? Again, if I know the x-coordinate is -1 of the vertex, that's going to be my axis of symmetry. The vertex is at the bottom of the graph, so this is a minimum value of y equals -7. Domain, blah, all reals. And then range, since the graph opens up or goes up from the vertex, we're going to say y is greater than or equal to -7. So that's how we would graph that quadratic in vertex form. I'd like you at this point to pause the video, go ahead and try this one on your own, and then we'll come back. Well, I'm not going to pause, but you pause here, try to graph this one using the method that I've shown. All right, so we got left 2 and down 8. Okay, so left 2, down 8, my vertex is going to be down here at -2, -8. For the table of values, I'm just going to do y equals 3x squared. Because it's a whole number in front, I can just use my typical my typical -2 to 2. To fill out the y coordinates, the equation tells me y is just 3 times x squared. So square it times 3, square it times 3, square it times 3, square it times 3, square it times 3. Now I'm going to graph those coordinates, but again, this is my new 0, 0. Okay, so -2, 12. Oh boy. Be up here, I think. -1, 1, 2, 3 is right there. +1, +3, and +2, +12 is up there. Okay, so this is giving me my parabola using the vertex down. This is how I graph the equation in vertex form. Again, -2, -8, which means my axis of symmetry is -2. The vertex is at the bottom of the graph, so there's a minimum value of y equals -8. Domain's all reals. And then the range, it doesn't hit every y coordinate, but that parabola goes up from -8. So we're going to say y is greater than or equal to -8. Whew. Again, not the most popular method, but it's the method that I like probably the most to graph in vertex form. Some teachers are going to have you graph y equals 3x squared and then subtract 2 from all the x coordinates and subtract 8 from all the y's, and you can certainly do that as well. I just think it's a little bit clunkier, and I don't think it's that big of a jump to just treat -2, -8 as our quote 0, 0. Okay. Now, last thing I want to talk about here is how do we go backwards? If I give you an equation of the parabola, how do we go backwards to figure out what the equation is? So the easiest thing is going to be to figure out what are the coordinates of the vertex. Okay, so the coordinates of this vertex are 3, -5, which means that this graph moved to the right 3 and this graph moved down 5. So to show that a graph moves right 3 and down 5, I know I'm going to have x minus 3 squared and then minus 5. The problem is I don't know this a value. Okay, there's a couple ways to do this. There is a shortcut method to figure out what the a value is. But what I want to do is I want to use this. I'm going to use any other coordinate on the graph. Okay, what we've seen in math before is if there's one variable in an equation that you want to solve for, as long as that's the only equation as long as that's the only variable in the equation, you can solve for it. So if I take this coordinate if I take this coordinate right here, which is 4, -3, I'm going to plug in 4 for x, and I'm going to plug in -3 for y in the equation we just wrote. Okay. And again, this is vertex form. So there's an a value, and then I know it's right 3 and down 5. So what I need to do here is replace y with -3. I don't know a yet. X is 4, and then -5. So now if I start to simplify this, especially this part, this is the part that's going to make this easy for me. 4 minus 3 and then square it. Okay, well 4 minus 3 is 1, and 1 squared is 1. So what this becomes is -3 is equal to a times 1 minus 5. Or you could just say -3 equals a minus 5. Now I can clearly solve for a by just adding 5 to both sides. And that tells me 2 is my a value. Now I'm not done. Okay, what I'm going to actually do now is write the entire equation that I started with up here. I'm going to replace a with 2. So y is equal to 2 times x minus 3 squared minus 5. This is the equation. I'm going to erase that. This is the equation for the parabola that's on there. So start with your vertex, pick any other point on the parabola, and we can solve from there. Okay. All right. If we try this again, I know it's opening down, so the a value has to be negative. There's got to be a negative in there somewhere to make the graph open down. But if we start with this vertex method, and we say this is 1, 7, okay, then I know it's going to be y equals a times x minus 1 squared plus 7. Because this is right 1 and up 7 from your typical vertex. Okay. Now the next coordinate that falls on a grid line is until all the way over here at 4, 1. So we're going to do 1 equals a, don't know, 4 minus 1 squared plus 7. You can replace x with the x coordinate I found and y with the y coordinate. Okay, so 4 minus 1 is 3. So then 4 minus 1 squared is going to be 9. So this will be 1 equals 9a plus 7. I subtract 7 from both sides. Okay, that gives me negative 6 is equal to 9a. And then divide by 9. And I get a is equal to negative 2/3. Oh, shoot. Gosh dang it. So I made a mistake here. That's all right. This stuff happens. This is not 4, 1, and maybe you're screaming at your iPad right now. This is 3, 1. So this should be a 3. 3 minus 1 is 2. 2 squared is 4. So there should be a 4 there. My bad. 4a divided by 4 divided by 4. My a value is actually going to be negative 1.5 or negative 3/2. So you get y equals negative 1.5. X minus 1 squared and then plus 7. That is the equation of the parabola there. My bad. Well, we figured out the mistake, which is good. Okay. The last little piece of this equation that we're going to do is, now it's the exact same thing. If I tell you the vertex and it goes through the point 2, 2, okay, since the vertex is 4 and negative 8, okay, I'm going to have y equals a times x minus 4 squared minus 8. This gives me right 4, that gives me down 8. And then I'm going to use the 2, 2 right here to figure out my a value. So I'm going to replace x with 2 and y with 2. Okay, so I'm just filling everything else that I know. This is the most important part. 2 minus 4 is negative 2. If I square negative 2, I'm going to get positive 4. So 2 is equal to 4a minus 8. Now I can solve by adding 8 to both sides to get 10 is equal to 4a. Divide by 4, divide by 4. A is 2.5. 2.5 times x minus 4 squared minus 8. That is the equation. And that is the only parabola that has a vertex of 4, negative 8, as well as goes through the point 2, 2. Okay. That's going to do it for the first video. It's a little bit longer. Good luck.